Today, we're going to be doing some reflections without the reflection tool. We're going to start out simple and then get it slightly more complicated. We're going to break it down very slowly because guaranteed on this quiz tomorrow, by tomorrow I mean Friday, you're going to make dumb mistakes. And you shouldn't. You really shouldn't. You really shouldn't. So we're going to do our best to make sure that does not happen, especially since not quarter grades, but midterm grades for quarter 2 are due Friday. I've never been at a school that does midterms for quarters, but you guys do. So sending home those progress reports, letting mom and dad know what's up. First thing you need to do, graph this line, y equals 2x minus 2. It's in slope-intercept form because it gives you the slope and the y-intercept. No, it's not. And then a is negative 4, 5. We're skipping warm-ups this week. That way we can get in a quiz right before those midterm grades go out because we don't have a lot of grades in the grade book right now. In fact, we have to just take a 0 because we've had so many days off and I've delayed on quizzes, which means we've delayed on homework because homework is due the day of a quiz, right? So trying to help you guys out here.
Hey. Speaking of quiz, I have to up to one quiz or someone else has been.
Yes.
Can I do that
Do we have a one?
If you're ready for it. No.
Hey, can I make up the second quiz?
Are you ready for it?
Yeah.
Oh, I lied to you, Mr. Mack. I'm sorry I didn't come at 7:30.
That's all right. I had a meeting this morning at 7:30, so I had to cancel stuff anyway, which is why I sent out emails to certain people that I remembered.
I gotta get a couple of days done.
I will actually.
Because you totally would have been here, McKenna, but
No, I actually wouldn't.
I know.
I planned on coming tonight. I still plan on.
That's cool. I'll be here.
I know, that's why when I get up here, I had to stand on the deck.
Can I
Yeah,
see it?
his one ball took up 9 times, so I had to stay here till 8.
We play basketball.
Unfortunately.
Graph the line and the point.
Kenna. Yeah, she loves it.
I don't know.
It's literally.
You don't want to die, honey.
It's just Mr. V's practice. Mr. V's is good, then Miss Grimm comes in. I'm like,
Mr. V, I dominated that guy. He's so short.
You guys are real tight, so.
It's easy.
Oh, need one for basketball.
Rosie? Oh, hey girl, what's up?
You guys good?
So we just have
All right. Just want to make sure like nothing happened.
I'm just keeping
All right, gotcha. That's a good.
What's the objective, sir?
All right, here we go. Graphing the line. It's in slope-intercept form because it gives you the slope and the y-intercept. So when I go to graph this thing, I'm going to go to the y-intercept at -2, which gets us a free point, both on your quiz and here. Yep. So then we're going to use our slope, which is 2, meaning 2 over 1. We're going to go up 2 over 1 from there. Again, whenever we start on a point and then use our slope, we're able to find 2 points that are on a line and 2 points make a line. Now, the reason I called this LOR stands for a line of reflection. That's going to be our line of reflection from the other day, you might recall, when we got out the McDonald's toys. We placed our little reflector on the line of reflection, looked through it, and found out where it reflected to. We're not going to do that today. We're going to use algebra to reflect points, which you're all going to love. Also, where did it go? Here it is. Plot your point, -4, 5. 1, 2, 3, 4 to the left, and 5 up. 1, 2, 3, 4, 5. And that is point A. And we're going to reflect that across this line. Now, when we reflect something, 2 things are always true. 1, when I look in the mirror me is the same distance from its mirror as I am from my mirror. So A to this line is going to be the same distance from this line to where A prime is, the reflection, right? Not only that, but when I look in the mirror me is facing directly across from me, perpendicular to the mirror, right? As I turn, so does mirror me. So we need to figure out where A is going to be. We're going to find the line that A is going to be resting upon, right? It's going to be 90 degrees. That looks about 90, right? It's going to be somewhere along that line. And then it's going to be the same distance across, right?
Sir.
Protractor's back there.
I got you. Do not move out of your seat.
All right,
Oh my
so
God.
first off, we need to find the line that A is going to be on. So to find that line, we need a perpendicular line.
Oh my God. You're dumb. No. Not dumb. Immature.
Your hope of passing this quiz on Friday rests pretty much on today, so make sure you're really paying attention, okay? All right, so we need to find a line that's perpendicular to the blue line and goes through point A. We've been doing that, right? Last week, what we did for our quiz is we did something along this, which you guys mostly did okay with. They gave you an equation, you graphed the line, they gave you a point, and they said, now find the equation that's parallel and goes to that point, right? Remember doing that? The dots, the points, and the lines?
Yes.
Carpenter? Points and lines? Last week?
Say
No?
yes.
The thing you were complaining about? I'm making a joke here.
You didn't get the dot.
There we go. All right, so we had to find a line that was parallel and goes to that point. We also had ones where it said perpendicular and goes to that point, right? So the first half of what we're doing is what we did last week. The next bit that we're going to do is we're going to find out where they intersect, and then we're going to use midpoint to find out where it would flip to. Cool?
Cool beans.
So, first thing we need to do is find a perpendicular line to this. What? Oh, that's not going to work. Thank you.
Sorry, I had to get a couple in.
No, it's all good. So, we need a line that's perpendicular to this one. So how do we find a line that's perpendicular?
Wouldn't it be
Flip and negate. So we flip the slope, which is 2 over 1, and make it 1 over 2, and then change the sign to make it negative, right?
yes?
Cool. Now, we don't know what b is, but we can go looking for it. Again, this represents all possible perpendicular lines. There are a lot of perpendicular lines to the blue one. I could draw a line here, and that would be perpendicular. Same thing here, it would be perpendicular. We want the one that is perpendicular and goes through that point. What is a line? A line is a collection of points that when you plug in those points to the line's equation, makes a true statement. So that point right there is 1, 0, right? Which means when I plug in 1 for x to the equation, I should get 0 for y. 2 times 1 is 2, minus 2 is 0. Checks out, right? All of these points along here are solutions to this equation. If we want this to be on this line, this point right here, then we need it to be a solution to the equation, right? So negative 4, when I plug in for x, after doing all the math over here, should pop out 5 for y. So the question is, what does b have to be to make that happen, right? So that when I plug in negative 4, I do math with b, and I get 5 for y. So in other words, we're going to plug in our point here to figure out what b is. 5 for y,
I think it's 3.
and negative 4 for x. When we do that, we have multiplication with fractions. First off, we have 2 negative numbers being multiplied, so that's going to be a positive answer, right? So ignore the signs now. We have 4 times 1, which is 4, divided by 2, 2, right?
Yes.
Another way to think of that is 4 divided by 2, the bottom, right? You get 2, times the top, still 2. Another way to think of that, multiplication is of, right? Half times 4 is really half of 4. Half of 4 is 2. Again, the answer is positive because it's 2 negatives. Then we subtract 2 from both sides, and we get 3 equals b. So it turns out b has to be 3, so that when we plug in negative 4, we do get positive 5, our point. So our equation is going to be y equals negative a half x plus 3. That's going to be our perpendicular line that goes through A. 2 ways to graph this. 1, just like we did with the blue, we start out with the y-intercept and do the slope, right? Our y-intercept here is 3. Our slope is down 1 over 2. You can do that. What happens when this number isn't nice? Because sometimes when you do math, numbers don't turn out nicely, right? Here's what you're going to do. Okay, another way to think of it. Again, you could graph it just like you did the first one, but we all did that, so I think we can skip that and go to the other method, right? Here's what I would do. I'd say, look, I know my slope is negative a half, right? And I know A is on the line. Well, if we start from a point that we know is on our line and we do our slope, aren't we going to find another point that's on the line?
Yes.
Yeah. So I'm going to go down 1 over 2, my slope, and I'm going to get another point. In fact, I can keep doing that, and you'll see where the y-intercept is. It's at 3, right? And that's going to help me make a straighter line. So you don't always have to graph it, intercept first and then slope, right? You can use your brain and graph it from what you already know. So somewhere on this red line is going to be A prime. Somewhere on this half of it, right? Cool.
Does that mean for sure will you have a like if you keep going down from your original A, will you hit the somewhere on the X?
The y-axis, yeah. And somewhere on the x-axis. Yeah.
Alright.
And again, if you graphed it like you would normally, right? Plus 3, that's 3 on the y-axis, right? Down 1 over 2. It's still valid, right? When it's convenient, graph it this way. But if you get a really nasty y-intercept, who cares? Use your slope. No big deal. So, that's nothing new. That's what we did last time. How do we feel about this stuff? Okay, so we're going to play a game. We're going to be doing it all day, okay? I could have been a doctor, right? I told you I almost went to med school. I chose music at the last second. All right. So to be a good doctor, what you have to do is you have to ask them, where does it hurt? And they say, it hurts here, right? And they say, well, what do I do? It hurts when I do this. Well, the doctor responds, well, don't do that, right? So here's what we're going to do. We're going to poke around, figure out where it hurts. This part right here, does that hurt? 2x minus 2. Feeling good about that?
Yeah.
If that was the quiz, you'd be like, praise God, right? What?
I just figured out I can dislocate my wrist.
2x minus 2. Graphing it. Feeling good? Autumn. Do you know how to graph 2x minus 2?
Yeah.
Awesome. Excellent. So it doesn't hurt there yet. What about this? Flipping the slope and negating it.
Yeah.
Feeling amazing?
No.
2 is 2 over 1. Flip it. We get a half. Change the sign. It's now negative. Got it. Okay. Awesome. Cool. Then we plug in our point because we want that point to be on this line, right?
Yeah.
So we plug in our point. We do math and we get b is 3. The math here was negative a half times negative 4. It's going to be a positive answer, right?
Yeah.
Half of 4 is 2. Okay, cool. Then I subtract 2 and get 3.
You showed us how to get that really like open thing. So.
That's what I'm doing here. So b is 3, which means this was 3 the whole time. Then we graph this just like we did the blue one if you want. Up 3 and then down 1 over 2. You could also go from A and do down 1 over 2. No big deal.
It doesn't matter.
Now, we want to know where these intersect. And could you eyeball it on this one? Yes. Why do I start with nice numbers and nice intersections? Because then the numbers are easy and we can just focus on the concept. I know you can eyeball it, but you won't be able to all the time. Spoilers for Friday. Yes.
I'm gonna ask the 2 original blue dots. One, the negative 2 is because of the b, but is the 2 because of the 2 and the 2x?
So the negative 2 is because of the y-intercept, b. And then 2 is up 2 over 1 for the slope. You dig?
Yeah.
Great question. All right, so we need to know where these lines intersect. Well, it looks like they're going to intersect at 2, 2. Spoilers, they do. But not always will they be so nice. Not always can you eyeball it. So we need a method that works algebraically so we can get the coordinates, right? So where do the lines intersect? Really, we're asking where do they equal each other, right? Every point on the blue line is a solution to this equation, right? 1, 0. When you plug in 1, you get 0. Every point on the red line is a solution to the red equation. So when I plug in, I don't know, this one right here, negative 5, 4, or negative 4, 5. When I plug in negative 4, I get 5 here. We want to know when you plug in a number for x to both of them, where do they both get the same number for y? Where do they agree? In other words, if y equals this and y equals that, don't they equal each other? They should. The question is where, right? Well, it's going to be right there. Where is there is what we want to know. So we're going to set these two equal and find out where. So 2x minus 2 should equal negative a half x plus 3 by substitution. Now, what value of x is going to make these equal? Well, it's going to be where these agree. Spoilers, it's 2, right? Now we're going to do math. Is everybody cool with setting these equal? Do we see why we're doing it?
Yeah.
Because we want to find the point of intersection, right? Cool, great. Now the math's going to get a little weird, but you're going to be fine. Bear with me. If you don't want to write down any of this next part, don't. Just watch the magic, okay? We learned something the other day. How to learn. Okay. Think while I'm doing it. Here's what I'm going to do. I'm going to add 2 to this side. That's going to make that a 5, right? I'm going to add a half x over to this side. Since they're not common denominators, I'm just going to write it, and we're going to get common denominators in a second. Is everybody cool with how I got there?
Okay, yeah.
You dig?
Yes.
Awesome. If you don't get something, stop writing. Or just be preemptive and know that you're going to screw up something eventually, so stop writing now. Your choice, okay? So, now we're here. We need common denominators. How many halves are in the number 2? Because I've got halves here. I need halves there. 4 halves in the number 2. Because there are 2 halves in 1, right? 2 over 2 is 1. 4 over 2. 4 divided by 2 is 2. We didn't change the problem. We just made it look different. 4 divided by 2 is still 2, right? So I've got 4 halves and 1 half. How many halves do I have? 5 halves. Are we good? Common denominators. Maybe you prefer common denominators like this. I will show it very quickly, and then we'll get back to the action, okay? We had a problem of 2x plus a half x, right? That's 2 over 1x. That's 1 over 2x. I need denominators to match. What did I do to the 1 to make it a 2? No. What did I do to the 1 to make it a 2? I multiplied by 2. So I multiplied the bottom by 2 to get that, right? Now, timesing the bottom by 2 is the same thing as timesing by a half. That changes the problem, right? We're not allowed to do that. But if we times the top by 2 as well, it's all good. Why is that true? Because timesing the top and bottom by 2 is the same thing as timesing by 2 and then dividing by 2. They cancel each other out. Another way to think of it, what's 2 divided by 2?
1.
So I'm just multiplying by 1. And does multiplying by 1 ever change anything? No. So we're not changing the problem. It's just looking different. 2 times 1 is 2. 2 times 2 is 4. And now we have halves. I have 4 of those. You have 1 of those. We have 5 of those. 5 whats? 5 halves. You dig?
Yes.
Wonderful. Now we're here. One way to do it. Some of you are going to get this. And if you don't, that's fine because I got a method too. Okay? First thing, I want to get rid of the 5 halves. I need to divide that off the x, right? Because it's multiplication. But we don't divide by fractions, right? We multiply by the reciprocal. So you know how to do that. Cool. Awesome. For those of you that don't, if I gave you 5x, how would you separate the 5 from the x? Divide, right? Cool. What if I gave you x divided by 2? What would you do to get rid of divide by 2?
Multiply.
Multiply by 2. What if I told you that is that? It's both of those at the same time. You can do either or. You can get rid of the divides by 2 first or the times 5 first. It doesn't matter. If you get rid of the times 5 first, it's kind of weird because you're going to divide by 5 and you're going to get a half x equals 1.
Wow.
Okay? I'm going to get rid of the division first, which is how you make a better world. You get rid of all the division, right? Bring people together. That's what we're about. So I'm going to get rid of division when I can. There's no rule about this, but it's generally a good idea. How do I get rid of divides by 2? Multiply by 2, right? What cancels divorce? Multiplication. Right? So, when we get rid of the divides by 2, all that's left is times 5, right? So 5x. We got rid of divides by 2 by multiplying, right? So I do that to both sides and I get 10 here. Are you smelling what I'm stepping in?
Oh, yes, I remember learning this at some point.
Yeah.
Now we divide by 5 and we get 2.
That's just amazing. You know what? Yeah, I should give you
Oh, I remember that.
I should give you a hug right now, but that's kind of weird.
Fractions are not hard. They don't have to be. You had like 8 years to learn this and they just like screwed around the entire time. I don't know what you guys did.
I like those years, though.
So where they intersect is what we're looking for. That's why we set them equal, right?
Yeah.
Where they intersect is a coordinate. So we found part of the coordinate, the x part, right? It's 2. Now we're going to go find the other part. We know that we have 2 here, meaning that when we plug in 2, we should get some y value. Well, we can figure that out algebraically, right? You can visualize it, right? But like that's a coincidence. Figuring it out algebraically, if I plug in 2 to either equation, it's going to give me the same answer because they agree there, right? So I can plug it into the top equation, or I can plug it into the bottom equation. Which one would you rather do?
Top.
The top one. Plug in 2 for x. 2 times 2 is?
4.
Subtract 2. 2. Oh, wow. What a coincidence. They're both the same. And it is a coincidence. Okay? Wow. Okay? So this is where they intersect. That's our midpoint. 2, 2. We're going to pause for station identification. Here's what we've done so far. This is what we did last week. Graph the first line. Flip the slope and negate it. Find B. Graph it. This is what we did just now. We found where they intersected, where they equal each other. We did math, and we got x equals 2. Then we plugged 2 in to either equation, and we got y. If we had plugged it into the bottom one, we also would have gotten 2. Negative a half times 2. That's half of 2. 1. Negative version of it. Negative 1. Negative 1 plus 3. 2. Okay? How we feel?
Hi.
All right.
Alright.
So how did you?
Yes.
No,
Ask.
I'm gonna sound like an idiot.
That's okay. Please.
No, never mind. It's fine.
Go.
Say it. Say it.
You have a problem probably this big that's causing a huge issue for you because you're just not seeing it. So how about you let me fix it? And no one will think you're dumb. You just haven't seen it yet. Remember the triangles?
What?
What?
How many triangles are
Say
there?
Illuminati.
You remember this?
Yeah, you're so immature.
No.
2.
Now, you said 3. It's not because you don't know what a triangle is. And it's not because you don't know how to count to 5. Because if it was those things, you wouldn't be an idiot, right?
5.
But it's just you don't see it yet.
2.
You're not an idiot. You just don't see it yet. 1, 2, 3, 4, 5.
That doesn't count.
Right? 1, 2, 3, 4, 5. Again, when you have a problem this small, it's not that you're a dummy. It's just you haven't seen it yet. So help me help you to see it. What, are you sure? Okay. All right. So here's the concept. We know A prime, the reflection, is somewhere on this red line, right? We know that it's going to be the same distance from here to here. So we're going to use midpoint formula. Normally, midpoint says, give me 2 points, and I'll find the middle, right? But we can also use it to find the other point, right? We've done that in the past. It was that weird question everybody hated on that one quiz, right? It was like reverse midpoint formula is what I called it. We have 2 endpoints and a midpoint.
Yeah.
They gave you 1 endpoint and a midpoint. We're going to find the other endpoint. It's going to be all right. You're going to get it this time, okay? So we're going to use midpoint formula. I mentioned that, okay? All the rest of that didn't mean anything to you, but I said midpoint formula. That sounds like something. Let's talk about what it is. Midpoint formula, okay? The midpoint, first of all, is a coordinate, right? It's a midpoint, a point, right? So it's the midpoint is some coordinate, commas, or I'm sorry, a parentheses and a comma, right? What is the midpoint formula? What's the idea, the concept?
Isn't it the average?
Average of the what?
X's and the Y.
Exactly. The average of the x's and then the average of the y's. The average of the x's, the average of the y's. We're finding the average point, right? The midpoint is the average point between 2 others. So, when we average stuff, do we add or subtract them?
Addition.
We add them, right? We add them all up and then we do what?
Division.
Divide by the number of pieces. That's what I'm talking about. So we're going to add up our 2 coordinates. We have 2 x values, an x2 and an x1. And we're going to divide by the number of pieces, which of course is 2. There's 2 of those guys, right? We also have a y2 and a y1. We're going to divide by 2. That's midpoint formula. The average of the x's, average of the y's. If you don't think of it that way, it's going to be a crapshoot. Is it add or subtract? I don't know, right? Sometimes we add, sometimes we subtract in here. Depends on the formula. If you know that it's average, think about what averages are. Add up all the numbers, divide by the number of numbers that you used, right? That's midpoint formula. Okay? So, we know 2 of our points. We know the point they gave us, and we know the midpoint. We found it, right?
Yeah.
So let's plug that stuff in and find the point we don't know. This point here, somewhere down here, right? The midpoint we said was 2, 2, right? So 2 comma 2. We're adding because it's average, right? Now, we know one of our points. One of the endpoints is negative 4, 5. That's the one they gave us. So I'm going to plug that in. You could plug it in here and here, or in here and here. Doesn't matter. I always just plug it in here. I don't know why. Whenever I plug something in, I wrap it in parentheses.
So it's not even
Good try.
I tried.
So we know this one. That's the original point they gave us. Everybody cool with that? All right, I need you back here.
Sorry.
Are we cool with this? Do we know why I plugged that in there and where it came from?
Yes.
Good. Now I'm looking for the other point, right? My A prime, the reflected point. That's going to be these guys, right? Cool. So now we're going to solve. This is a coordinate, that's a coordinate, right? So if this is 2, this thing, after all said and done, should be 2 if they equal each other, right? Same thing here, right? These should equal each other, and these should equal each other. So this should equal that, and that should equal this. It's just a coincidence they're both 2s, right?
It's not always going to be like
It's not always going to be like that.
There better be like 2 questions on this quiz.
That's fine.
Yeah, so if you miss one, you get 50?
Yeah.
Yeah, great idea.
Nice one, bud.
So we know this equals that, right?
Yes.
What's an easier way to write x plus negative 4?
X minus
X minus 4. So I'm going to do that. I didn't lose anybody, did I?
No.
Cool. All right. I also know that this equals that. So 2 should equal 1 plus 5 over 2. All right, one problem at a time. Let's solve this one. We want to get x on its own so we can figure out what the x value is of this reflection.
4.
We're going to multiply by 2, and then we're going to add 4, right? So multiply by 2, we get 4 equals x minus 4. Then we're going to add 4 and get x is 8. Cool?
Yes.
Then we're going to multiply by 2 here and get 4. And then we're going to subtract the 5, right?
Yeah.
Negative 1. There's A prime, the reflected
Okay.
point.
That's not as hard as it looks like when you set it up.
Now we're going to draw A prime on our graph. 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. If it was 8 to the left, we'd really be in trouble, right? And then down 1. Looks legit.
Oh, pretty neat.
Go.
How do you like them apples?
Now we're going to play the game. Where does it hurt, right?
That's gods now.
How do we feel about graphing the original line? Autumn has a thumbs up. That's good. Graphing the original line. How do we feel?
That's goated.
Good. So I better not see any of these blank, because you can at least do that, right?
Yes, sir.
Wonderful. Can you plot the point? I swear to God. All right. Can you flip and negate the slope? Awesome. There's 3 points. We're on our way. Can you solve for b by plugging in the coordinate?
Of course.
Of course! Can you then graph that line?
Hopefully, yeah.
Same as the blue, right? Graph it the same way. Y-intercept is 3, down 1 over 2. If you have a gross number there, use down 1 over 2 from your point.
That's
Can you set them equal? I don't care about this. Stop here. Can you write that? Set them equal. That's a frickin' point for setting it up.
How many points is this question?
I know! So, then you do math. We get 2. Ignore the do math part, okay? We get x on its own.
Yes.
In theory, can you get x on its own? In theory, algebra hard, geometry easy. I know, right? But in theory, you did it, right? You've done it before. You can probably do it again, right? Then we'll do it again. X is 2. So x is 2.
Yes.
Can you plug it back in and get the other one?
Yeah.
Yeah, you can. Plug it back in here, right? Awesome. You're more than halfway through. Well, the last bit is literally just plugging in the point you found and the point they gave you.
So is that like...
And you're done. This is right here on this page, right here. What we did on this page is 2/3, if not more, of the points on this question. Graph the line, flip the slope, negate it. Graph the new line. Find where they intersect.
Excuse you.
After that, do midpoint. Take the point you found and the point they gave you. Do midpoint with it. Find the missing point. Do you feel about 50% good on this?
Yeah.
Maybe a little bit more?
I'd say 50.
I'll take that. Tomorrow it will be cemented. I told you yesterday was the day where you're like, oh my God, this is hard. And then today, what did you say?
Okay. Yeah, I got this.
Yeah, you're like, wait a minute. This is what? That was it? Right? Yeah, I know. I'm a professional. Sort of. Tomorrow, you should feel real good. Here's what your quiz is going to be, okay? Not the quiz tomorrow, the review tomorrow, because we do review on Thursday and quiz on Friday. I swear to God, some of you still don't know this, okay? Here's what's going to happen. Your review is going to be very similar to your quiz, right? Talk about this. You should know this by now. Your quiz is going to be 50%. Half of it is going to be vectors and translations, sliding things around. Which, if you don't remember what that is, that's fine. That was 2 days ago and sort of yesterday. It's super easy in comparison to this. So if you're not sure about that, you will be by the end of tomorrow. It's super easy, okay? That's 50%. Take advantage of that. A quarter, so we're up to 75 now, right? A quarter, 25%, is going to be this kind of thing right here, okay? With nice numbers and stuff you can eyeball. But you better do the work, because when you don't eyeball this correctly, I will take off points. I swear to God, okay?
I swear.
We're going to do one that doesn't have nice numbers now, okay?
No.
That's going to be the other 25% of your quiz, okay? And 25 is a relative estimate. It's probably less than that, okay? Now. Oh, man. So, this has a nice intersection and had nice numbers, right? I'm not a crook. The next one we're going to do is can have weird numbers, but everything else will be the same. We're going to do the same dumb crap, okay? Trust me on the math. We're going to graph our line. We're going to flip and negate the slope. We're going to graph the new line. We're going to find out where they intersect. We're going to find the intersection, and we're going to put it into midpoint formula. We're going to do the same dumb crap. Just the numbers are going to be a little bit weirder. It's going to be all right. Bear with me. You are not going to write any of this down.
Sounds good.
Absolutely nothing.
Do we even need these? Turn in.
No, this wasn't a warm-up slopper, but you missed that because you were in the bathroom. I understand. All right.
Rearrange.
Never again.
Please, God, no.
I think I was closer with my bottle cap than where I was with the
No, no, Justice, we were up there, dude.
Let's try to ricochet it back, man, like a boomerang.
Justice.
Yeah, that's what we're gonna do.
Who sits here?
Here we go.
Who sits here?
No one.
Can I sit here today?
Okay.
Yeah, go ahead.
Bothers me.
Can I see if I can ricochet the
No.
No.
We're doing so well today. Do you know why everybody's learning today? Because you're all trying to learn today. Keep up the good work.
Because we want to pass.
We wanna pass this.
Because we want to pass.
All right, I'm gonna give you a couple seconds. We don't have a ton of time in class left, but we have enough to do this. I'm gonna give you a couple seconds to do whatever you need to do, and then when you're ready to like get back into this, tell me. I'm not trying to be mean here. I'm not like,
I
oh
gotta
wait,
get one flick out of this.
we're not doing that. That's not what I'm doing. Well, good try. So when you're ready to get back in the zone, watch the show. We'll get into it. Again, I'm not doing the I'll wait type of thing. I just want to be clear. Just giving you time to decompress. All right.
You look different on the screen than you look in real life. I think so.
Yeah, I mean the angle isn't very flattering, I suppose. All right.
You look white.
I know.
Okay, it's something
The white
making JD
balance.
laugh. He wants you to look at your phone.
All right, line of reflection for this problem is going to be y equals negative 3 halves, x minus 1. That's a minus 3 halves. Are we cool with that?
Nice one, Jacob.
Gentlemen,
Oh man, that's a good.
make sure you're ready to go when I'm done writing this stuff down.
It relates to
We gotta
Yeah,
drop
okay,
the
we all-
load. SpongeBob meme, you like it.
I do like SpongeBob.
Show me, man. Show me.
No, not right now.
Save it for the weekend reflection. You better put it up with them.
Meme review. This my second channel.
Mr. McAnally is here.
All right, you guys ready?
I guess. Disgusting.
Oh yeah, sorry, Rosie.
No, that's fine.
All right, you can sit behind Justice if you want.
What?
All right. So,
I'll decide.
ready? Here we go.
Yeah, let's go.
Watch the show. I'm gonna go quickly, okay?
And hold on.
Put your head back up.
I'm going to graph the original line. The original line has a y-intercept at -1. So when I go to graph it, I'm going to graph it right here. And then using that point, I'm going to use my slope down 3/2 to graph this. 1, 2, 3 down, and 1, 2 across. I'm going to draw my line of reflection. There's the line that we're going to reflect it across, right? The thing that we used the reflector tools before. Our point that they gave us that they want us to reflect is at 4, 6. 1, 2, 3, 4, up 6. 1, 2, 3, 4, 5, 6. We're going to call that A. Awesome. Now, I need to find a line that is perpendicular to this and goes through point A. Well, to make it perpendicular to the blue line is very easy. All I have to do is flip and negate the slope. It was negative, so it's going to be now positive. I flip it, now 2's on top and 3's on the bottom. B is what's going to make it line up with this guy, right? Right now, this represents all the possible lines that I could draw that would be perpendicular. There's lots of them.
Would it be minus B? No.
Mm-mm-mm. If B is negative, then it would be a plus a -1 or something like that, right? It's all good. They're not going to be the same, okay? This is y equals mx plus b form. That's all I'm doing, okay? So I need to find out what B has to be in order for it to go through this A point right here, right? So what I'm going to do is I'm going to plug in this point, 4 and 6, to figure out what B has to be to make that true. So I plug in 6 for y, not 4. Just because it's the first thing you see doesn't mean it goes there. You're going to make that mistake tomorrow. I swear to God. Don't do that. 4 goes with the x, 6 goes with the y.
Oh, 6 is a Y.
And that's why we said it. And then we're going to plug in for x whenever we plug stuff when we wrap it in parentheses, right? So we're going to plug in 4 here. Again, 4 goes with x, 6 goes with y. Now, we're going to do this. Again, the numbers are going to be more gross this time, but it's going to be okay. We have 2/3 times 4. In other words, we can do 2 times 4 first and then divide by 3. Or we can divide by 3 first and then times by 2. Doesn't matter. I'm going to times by 2 first. We get 8. Then I divide by 3. 8 divided by 3, what's that?
8/3.
8/3.
That's why.
Fractions are division for lazy people. What's 8 divided by 3? 8/3.
8/3.
Why didn't we teach you this before? All right, now I need to subtract 8/3. It's going to be fine. Bear with me.
Why did we do it the other way? Just saying.
Now we're here
6/1.
because we need the equation. You were thinking of doing it from the point with the slope? Yeah, we need the equation to set them equal. All right, so now we're going to subtract 8/3. We need common denominators.
6.
How many
Use 3.
thirds are in the number 6?
2.
Nope.
3.
6/3 would be 6/3. Pause. 6/3. Let's check that. 6/3. Is that 6?
No.
No, 6/3 is 2, right? So not quite. How many thirds in the number 6?
18.
Is 18 divided by 3 6? Then yes, then there are 18 thirds in 6. 3 thirds in 1, 6 thirds in 2, 9 thirds in 3, so on and so forth until you get to 18 thirds in 6. Okay? 18 minus 8 is 10. So we have 10 thirds. That's B. So our equation is y equals 2 thirds x plus 10 thirds.
Thank you.
I'm going to walk you through it one more time. We started here. We plugged in our coordinate. 4 for x, 6 for y. We did multiplication. 4 times 2 is 8. Divide by 3. 8 thirds. Then I subtracted 8 thirds. I got common denominators. 6 is the same thing as 18 over 3.
Yeah.
18 thirds minus 8 thirds. Well, that's just 18 minus 8, which is 10. 10 what? 10 thirds. You dig? It's kind of like a unit.
And you fill it back in for B.
You plug that.
Then I plug it back in for B. That's the equation. Now, I'm not going to graph it by putting this as my y-intercept. Good God, no. Why would I do that?
What is going on?
Okay? All I need is one point that I know is on the line, and then I can use my slope up 2 over 3 to find another point. Well, luckily, I already know one point that's on my line. So I'm going to go from there and do up 2 over 3, and I've got another point. I could also, if my graph isn't big enough, go down 2 back 3, right?
Yes.
Because 2 thirds is the same thing as negative 2 over negative 3. Up 2 over 3 is the same thing as down 2 back 3. So now I draw my line, and I know that A prime, the reflected point, is going to be somewhere on this red line. Cool?
Yeah.
Awesome. Where is it going to be? Well, it's going to be the same distance on both sides. So I'm going to use midpoint formula to figure that out. For midpoint formula, I need to know what the midpoint is. It's going to be where those two lines intersect. Now, could you eyeball that here? Yeah, you probably could. But we need to know for sure. How do I figure out where two lines intersect? I set their equations equal to each other. If this equals y, and that equals y, then doesn't this equal that? It should somewhere, right? The question is where. That's what we're trying to figure out. So what I'm going to do is I'm going to take negative 3 halves x minus 1, and I'm going to set that equal to 2 thirds x plus 10 over 3. It's going to be okay. You're going to be fine. You're going to be fine. I'm going to add the 1 over to this side. These are going to go together because it's regular numbers, right? How many thirds are in the number 1?
3.
So when I add 1, I'm really adding 3 thirds, aren't I? Are you smelling what I'm stepping in?
Yes.
So I'm adding 3 thirds to 10 thirds. How many thirds do I have?
13 thirds.
13 thirds. I'm going to move over the 2 thirds x. When I move stuff, I either add or subtract. I'm moving all of that. So I'm going to do what? Subtract it. So I've got negative 3 halves x already there. And I'm moving over the 2 thirds x by subtraction. I'm moving the whole thing over, right? When we move stuff, it's adding or subtracting. Division is divorce. Multiplication is right? So now we're here. Forget the x's. It's going to be x something, right? Negative minus another negative. It's still going to be negative, right? I need common denominators. Let's talk about this. The common denominator here is 6. 2 times 3 is 6. That guarantees we have a common denominator, okay? Everybody remember that from algebra?
Yeah.
Okay. Now, we can't just make these 6s and keep the 3 and the 2, right? That would be changing the problem because negative 3 divided by 6 is not the same thing as negative 3 divided by 2, right? So what did I do to make the 2 into a 6? I multiplied by 3. So if I multiplied the bottom by 3, I have to multiply the top by 3. Because that's the same thing as multiplying by 1. That's totally legal. Do we get that? That makes it a negative 9. Here, though, I didn't multiply by 3 to get that to be a 6. Right? Common mistake. What did I multiply the 3 by to make a 6?
2.
So I multiplied by 2 on the bottom and 2 on the top, which gets me 4. How many sixths of x do I have? Negative 9 minus 4.
Negative 13.
Are you getting it?
Yeah,
It's blowing your freaking mind, isn't it?
Realize something funny.
Gas.
Oh my god.
Cool?
Yeah.
Yeah.
If I told you this was 13 times x, what would you do to get rid of the 13 in front of it? If I told you that was 13x, what would you do? Divide by 13. Okay, so that's something we could do. If I told you that was x divided by 6, what would you do to get rid of the divides by 6? Okay, cool. You want to multiply by 6 and do 13 times 6? Probably not, but you could, right? 60 plus 18, 78 over 3. Dividing by 13 actually works out kind of nicely here. If we do it to both sides, check it out. What's 13 over 6 divided by 13? I'm going to pause so you can think about what I just did. I divided this by 13. I have 13 sixths. If I divide by 13, I only have 1 sixth. Does that make sense?
No. Oh.
Yeah.
No.
Think of 6 like apples. 13 apples divided by 13 is 1 apple.
How can you divide by 13 if the 6 is on the bottom?
Well, I'm dividing by 6 and then dividing by 13. Except I switched the order and divided by 13 first. And then I'm going to divide by 6. I divided this by 13 and got 1. I still have to divide by 6.
Alright.
Cool.
Yeah.
If I divide one side by 13, I have to divide the other by 13. This is 13 divided by 3, and I want to divide it by 13. Let's divide 13 by 13 first. What's that?
1.
1. And then I have to divide it by 3. A third. I have 13 thirds. I divide it by 3. I have 1 third. You smell what I'm stepping in? This is the hardest part of what we're doing. I divided both by 13. 13 sixths is 1 sixth. 13 thirds is 1 third. When you divide by 13. Now, how do I get rid of the divides by 6? Because that's what that really is, right? Multiply. Let's multiply by negative 6 to get rid of the negative 2. So I get 1x, which is just x, multiplying by negative 6. Negative 6 over 3, right?
What would you divide?
Multiply 1 by negative 6.
Wouldn't that just be that negative 2?
So, but how do you know? Like, how do you know? Like, since the
Look at it while he's talking. Think about it. Make sure you understand what I did and why.
the negative sign's in the middle, so how do you know if it goes up top or bottom?
Great question. I'll answer that in a second. Don't let me forget. I divided everything by 13 because that worked out really nicely, right? Both have a 13 in the top. And I got 1.
Yes.
Could I have multiplied by the reciprocal? Sure. I could have multiplied by 6 and divided by 13. Like this. 13 times 6, 3 times 13, simplify down, or you could cancel, right? You've seen that before. 1/3.
Yes.
Negative 2. How do I know, Schlaffer asked, how do I know the negative went with the 6 and not the 1? It could be either. All of these are the same. Negative 1/3 with the negative up top is the same thing as this with the negative on the bottom, is the same as this with the negative on the outside. They're all the same. Is this the same as the ones up top?
No.
No, because 2 negatives when you divide and make a,
Positive.
and these are all negative, right? So it can't be this. As long as you don't do it with both, you're fine. Pick one, the top or the bottom. In this case, I chose the bottom. X is negative 2. So the midpoint has negative 2 for x. How do I find out what the y is? I go back up and I plug it in. We're going to do this in our heads. A negative times a negative is a good. So ignore the signs. We're doing 2 times 3, which is, now divide by 2, 3. I put a 2 here. 2 times the top is 6. Divide by the bottom is 3. Are you with me? You could have also done 2 divided by the bottom and get 1. Then times by the top, get 3. What's 3 minus 1?
2.
2. Almost the same. Coincidence.
Wait, so what did you plug up?
I plugged in negative 2 here.
Alright.
Is everybody cool that I plugged in negative 2 here?
Yeah.
Trust me on the math. It comes out as 2. Our midpoint then is negative 2, 2. We know what A is. Let's go get A prime. How do we figure out where A prime is? Midpoint formula. What is the midpoint formula? Average of the x's, average of the y's. Midpoint is the average of the x's, average of the y's. When we average stuff, do we add or subtract? We add. We have 2 pieces, 2 x's and 2 y's. We divide by 2. We know the midpoint is 2, negative 2, if I recall correctly. Or is it negative 2, 2? Negative 2, 2. The point they gave us to start with was 4, 6. And the point we're looking for is whatever this x and y ends up being. You dig?
Yeah.
Let's solve. We're going to do it in our heads without writing it down. These two go together, right?
Yep.
Let's multiply by 2. What do I get? -4. Subtract 4.
0.
We are at -4 and we subtract 4. -8. These two go together. Hold on, Schlaffer's confused. Times 2, we get -4, yeah? Subtract 4, we get -8. -4 minus 4 more is -8. You were thinking it was 0. Happens all the time. These two are together. Times by 2, we get 4. Subtract 6, -2. So that means A prime is at -8, -2. And when we go to graph it, -8, 1, 2, 3, 4, 5, 6, 7, 8, down 2. It's on the line. It's equidistant. There's A prime.
Review tomorrow.
I miss doing these up on the board because when I get done with something that amazing, that long, and that crazy,
slam it
I
down.
slam the marker on the ground, and I can't do that anymore.
You can slam your camera.
These are expensive.
Oh, well then.
I'll see you tomorrow.
Oh, really?
That's as bad as it can possibly get. Other than the common denominators. Yeah, other than the common denominators and having to divide with fractions and stuff, you guys got it. Your boat horn?
Yeah, I brought the boat.
Does it sound like a foghorn? Is that what it sounds like? I give you permission to bring it in.
Really?
Yeah.
Can we honk it?
I might take it and keep it because I like if I like it. So just so you know,
Alright, I'm gonna bring my
I
boat
will
horn in.
seal it / confiscate it.
Actually, tomorrow we should go to my car, everybody.
Bye.
We can honk the paper horn.
Okay.
My boat horn's gonna.
Not 100% today, but a good day.
I'm bringing my
Thank
boat
you.
horn.
I do better when I sit back there because I can see better.
Right, and we're gonna have bad days, right? That's gonna happen. But the key is to maximize the good days. Thank you for doing that. I'm proud of you. Hi. Put this away before, I don't know, we need this. I hurt myself further. Cores. If anyone asks, I don't know what beard is, so I couldn't get you in trouble for that. My favorite kind. Go, Tucker. Good to hear. Of course. What could go wrong?